Welcome, ladies and gentlemen. I'm Terry Shoemaker with the Pacific Northwest National Laboratory, and I'd like to welcome you to today's webcast, Hitting the Target Energy Star SSL Outdoor Area Lighting, brought to you by the U.S. Department of Energy's Solid State Lighting Program. We're very happy to have our speakers today, Mr. Richard Karney of the U.S. Department of Energy and Mr. Jason Tuenge of the Pacific Northwest National Laboratory. Rich, please begin.
Thank you, Terry. I'd like to welcome everyone on behalf of the Department to this webinar titled Hitting the Target Energy Star Solid State Lighting Outdoor Area Lighting. We're pleased to host this webcast to provide you an update on criteria for several new lighting applications being added to the Energy Star for Solid State Lighting Luminaire program. These applications are outdoor pole-mounted area and roadway lights, outdoor wall-mounted luminaires or wall packs, and parking garage and canopy luminaires. It is perhaps an understatement to say LED outdoor area lighting is a very hot topic these days. The number of new products, demonstrations, and installations seems to grow daily. That interest is reflected in the response to this webcast. I anticipate close to 400 people will be listening in today, and I thank you all for taking time to learn more about LED outdoor lighting. But before we dive into the technical details of these criteria, I'd like to say a few words about the overall Energy Star program direction. Last week, an announcement was made of a new agreement between the Environmental Protection Agency and the Department of Energy related to the overall management of the Energy Star program. There will be a unified program led by EPA with ongoing technical support from the Department of Energy. An integrated plan specifically addressing lighting technologies, including solid-state lighting, will be developed over the next 2 months, and there will be an opportunity for stakeholder input. In the meantime, DOE will finalize criteria for the outdoor applications we'll address today, and also for integrated LED replacement lamps, and once finished, hand them over to EPA for implementation. Now on to our topic today, outdoor area lighting applications. I'd like to briefly recap where we are in the process of developing these criteria, and then I'll be turning it over to Jason Tuenge of Pacific Northwest National Laboratory to provide the specifics. As you know, draft criteria for these outdoor applications were published on July 1st, with stakeholder comments due by the end of the month. During that time, the Department received comments back from 18 stakeholders, including 13 manufacturers. We appreciate the very thoughtful and detailed comments provided by the stakeholders. Several important revisions have been made to the criteria in response to these comments. I'd like to highlight several key changes made to the outdoor area and roadway application in particular. First, many stakeholders noted that the draft Fitted Target Efficacy, or FTE, requirements for outdoor area and roadway luminaires were very high relative to LED luminaires available today. We have adjusted the required levels such that qualifying LED luminaires will have to be at least as efficient as the top 25% of incumbent fixtures using high-intensity discharge or HID sources. Second, the light output categories for outdoor area and roadway luminaires have been expanded to allow for better differentiation of applications where LED luminaires can compete and save energy today. The current state of LED performance allows for outdoor luminaires that can compete effectively with HID sources at the lower end and mid-output levels. LED technology continues to improve rapidly, and indications are that LED luminaires will steadily improve to compete even at higher output levels within the next couple of years. And third, the FTE metric has been adjusted to allow for non-symmetrical distributions, providing for greater flexibility in luminaire design to accommodate various application needs. These are just the highlights, and Jason will walk you through both the FTE metric and how it evaluates the performance of outdoor area and roadway luminaires and the specific changes proposed for the Energy Star criteria. We invite you to ask questions and provide comments online via the question feature on your screen. We will likely not be able to answer all questions during the Q&A portion of the webcast, but we will answer as many as possible. And I will assure you we will read all comments submitted during the webcast. We will use these comments as additional feedback as we finalize the Energy Star program requirements for solid-state lighting luminaires version 1.2. Well, thank you for your attention, and at this time I will turn it over to Jason Tuenge of the Pacific Northwest National Laboratory.
We will be covering 3 new subcategories to the Energy Star criteria for Category A solid-state luminaires. We're going to cover why we're adding these applications or these subcategories. We'll go over the draft criteria that were released in early July for public comment, go over the comments or some of the comments that we received, and cover some of our responses to these comments, and then wrap up by addressing our currently proposed revisions to the draft criteria. The subcategories are broken down based on the manner in which luminaires are installed. So we've got pole-mounted luminaires, which cover shoeboxes, cobra heads, and even acorns and lanterns, in other words, decorative luminaires. This category covers all these types because there's really no objective means of differentiating between them. The next subcategory is wall-mounted products. And last are products that are ceiling-mounted, typically for use in garages or gas station canopies. All of these luminaires are intended for installation above eye level, and so this excludes bollards and step lights. So why bother adding these subcategories? This is a very active portion of the solid-state lighting market currently. It's not something that's going to be happening down the road in the future. There's a lot of interest right now, a lot of products that are available right now. The caliper program has shown that there is a very broad range in terms of performance and also in terms of reporting of performance and performance claims. Demonstration projects have also shown that there is potential for energy savings, but that there's a lot of education that needs to happen to make sure that consumers are not disappointed. To start off, let's look at the ceiling-mounted luminaire criteria. That basically structured such that we have a requirement for minimum light output. It's not enough for a luminaire to be efficient. It also needs to produce a good amount of light. So we have a minimum light output requirement. We do have a minimum luminaire efficacy requirement, and also a requirement for minimum amount of light in the region between 60 and 70 degrees from nadir. This basically ensures that there is some degree of control. The light is being spread out so it can be used effectively. One comment we received for the ceiling-mounted draft criteria, was that the baseline was basically set too high, and the reason for this 70 lumens per watt requirement was that upon analysis of the predominant incumbent technologies, fluorescent and HID for these products, 70 lumens per watt is really needed to actually ensure energy savings. We're not setting the bar based on LED performance. So currently, we're not proposing any changes to the ceiling-mounted criteria. Next up is the wall-mounted criteria. Similar structure in terms of our requirements. We've got minimum light output, minimum luminaire efficacy, and also looking at zonal lumen density, but instead of having a minimum requirement, we're setting maximum restrictions on the amount of light that can be in these regions. And we're setting the structure based on the new luminaire classification system from IES, more commonly known as the bug rating system. And the structure of this system is shown here, basically with a high region between 60 and 80, and a very high region from 80 to 90, and then also some uplight regions. One comment we received for the wall-mounted products was that upward light is really by definition wasted because it will never hit the horizontal surface below. And the reason we had allowed some uplight in the past, even though it was a small amount, was to basically remain in line with IS as much as possible, because the bug rating system does allow some uplight for different applications. But for simplicity's sake and for the basic concept of wasted energy, we're going to go ahead and propose deleting the allowance for uplight. Moving on to pole-mounted luminaires. Again, a similar structure, minimum light output requirement, restrictions on flux in the high-angle regions. But now we're also introducing a more refined metric for luminaire performance, something that we developed called Fitted Target Efficacy. And the basic idea is that rather than stopping at light produced per watt consumed for luminaire efficacy, we're actually looking at the amount of light that's been produced, that's been delivered to the task per watt consumed. So it's actually useful light per watt consumed. One comment was regarding the minimum output value, wondering what the basis was in establishing this. We used a 35-watt high-pressure sodium lamp, basically the lowest wattage available, in a luminaire that is got significant house-side shielding, bringing its efficiency down to 50%. Another concern was raised regarding the bug rating system and the fact that we're not using it literally. We're basically used it to establish our restrictions. It's not something where it's simply referencing the bug rating system. We can't simply reference the bug rating system because bug system relies on knowledge of the application for the luminaire. What project is going to be, in what project will the luminaire be installed? What's the environment? Is it a dark environment, a bright environment? And when evaluating a luminaire, you cannot know what environment it will be installed in. So we had to make some adjustments. Another comment was that the uplight restrictions are too lenient. This is in line with the wall-mounted products. So again, we're going to simply eliminate the uplight allowances. There's concern that the restrictions we're placing on light in the high and very high regions will effectively discourage the use of what are known as high-performance luminaires. Basically, the idea here is that high-performance luminaires will often allow for greater pole spacing because you've got more light in high-angle regions. If you get rid of this, you have to tighten up your pole spacing. Along these lines, there's a concern that when you increase your pole or decrease your pole spacing, your lighting power density is going to go up. Really, if you adjust your wattage after tightening up your pole spacing, your lighting power density will not go up. So that's really a non-issue. As for the levels that were set, this is based on a correlation we made between the bug rating system and the old IS cutoff classification system. This is done to allow for evaluation at the luminaire level, not at the project level. I can't really get into details during this webcast due to time constraints, but you can see based on this next slide that where the bar is set currently, it basically discourages non-cutoff type luminaires, which produce quite a bit of flux in the very high region, while excluding only the worst of the semi-cutoff luminaires, and allowing most of the other products to move through. And this is really the intent. We're not trying to be overly conservative in terms of obtrusive light. We're just trying to at least prevent the worst offenders. Similarly, when you look at the high region between 60 and 80 degrees, basically what happens here is we're again very liberal, actually, allowing a fair amount of light in this region that does allow for broader pole spacing and is actually quite common out on streets and in parking lots. So this really isn't intended to cut out a lot of products. It's really just keeping out the worst offenders. So what exactly is Fitted Target Efficacy? FTE, as I mentioned before, the idea for it is basically to not just stop at luminaire efficacy, but which evaluates the luminaire based on light produced by the luminaire per watt consumed, but to actually look at light delivered to the task per watt consumed. And so the question is, what's the task? The basic principles of fitted target efficacy are that for light to be considered useful, it needs to be distributed uniformly, first, and second, that the resulting distribution of uniformly distributed light generally is most efficient when it's a rectangular shape. These patterns match up best with each other when covering a large area with minimal overlap and minimal spillage off the target. So how exactly does this metric work? It starts by producing this uniform area of coverage and counting all the flux that lands within. The boundary is defined based on the highest IS recommended uniformity ratio, 6:1 average to min. Counts all the flux landing within this pool, fits a rectangular target around the pool, and determines the percent coverage of this target by the uniform pool, and then scales down the lumens by the percent coverage and divides by input wattage to give you the effective lumens delivered to the target per watt consumed. The basic benefits of the metric are that it does look at luminaire efficacy, or delivered efficacy in this case. It is application independent to meet the needs of Energy Star. It does evaluate backlight. It does evaluate the shape of the distribution. Does not set any arbitrary proportions. It does look at uniformity. Leaves a good amount of room for flexibility for the market. And does not make any requirements in terms of area of coverage. It's important to note that it is useful when evaluating similar products, not dissimilar products. And so you don't want to compare a type 2 distribution with a type 5, or even a type 2 distribution with another type 2 distribution without evaluating the two distributions. Here I'm showing a type 2 short on the left and another type 2 short on the right. These are clearly not equivalent in terms of coverage, and would probably not behave identically in any application. So how exactly can you calculate FTE? We've developed software that allows you to do just that. You just load an absolute photometry IS file into the software that's available on the website listed here. You hit calculate and review the output, which will look something like this. Summarizing all the pertinent statistics, tells you whether it's shielded or unshielded, total output from the luminaire, FTE, the derived bug values in terms of percent output. It even tells you whether it's a type 2 short or other classification. So going to the comments that were received for the pole-mounted product criteria, we were asked basically why we didn't consider site-specific requirements like lighting power density, roadway width, number of lanes, so on and so forth. And that's not an option for us. We have to look at the luminaire itself and cannot know how it's going to be applied when you look at the luminaire. Any given luminaire can be applied in an infinite number of ways. There was concern that we had set the bar too high by looking at the 75th percentile HID performance and expecting a 20% improvement over that for Energy Star products, their LED. Upon further analysis, we agree and have decided to simply put the bar at the 75th percentile HID performance level. And this will still ensure a high level of performance and good energy savings for most projects. And additionally, to help encourage appropriate use of LED products for these applications, we're introducing a mid-output category, which effectively allows more products to appropriately be used in applications requiring higher output than the low output category. So we were asked to provide some summary data to illustrate how we set the bar for LED. Basically, you can see here the baseline HID lamp ballast efficacies that were used for our newly proposed revisions, which is the same method basically that was used before in our July draft criteria. We're looking at 73 lumens per watt for low output luminaires, 92 for mid, and 114 for high. This diagram shows the basic breakdown. It gives you a visual sense of what the existing HID products look like out there and how these baselines relate. You can see that the low output category basically covers lamp output up to 15,000 lumens. So again, that's the low output category. The mid output then goes up to about 47,000 lumens of lamp output. And you can see that this corresponds well to the existing data set out there. So then when you actually look at the luminaires that are currently available, shoeboxes and Cobra heads that were evaluated based on these lamp ballast efficacies, you can see where the 75th percentile places us in terms of expectations for LEDs. It puts you at the top of the pack, but not well above the pack. Basically puts you in competition with the best of the best that are out there. And then this next diagram shows the high output benchmarking data, and again, where this bar places us relative to the pack. There was a little bit of confusion as to whether products would be expected to meet our requirements in their full output mode or also a dimmed mode if it's an option. We will add a clarifying note to indicate that luminaires are indeed expected to meet this at full output and not in a dim mode. It was noted that some distributions are designed to be asymmetric left to right, and that the current algorithm or the draft algorithm would penalize these distributions. We've decided to go ahead and simplify the algorithm so that these distributions are not penalized. But it's important to note that FTE is not intended to be used for evaluation of luminaires that were designed for small target visibility. It's not anticipated that there's a strong correlation between these two metrics. There was concern as to the selection of uniformity criteria. Basically, the criteria were based on the most lenient IS recommended uniformity ratio, which is 6:1 average to mid. When you're evaluating all these products in terms of FTE, if you evaluate them just in terms of 6:1 average to min, you find that the uniform pool is lit to 30:1 max to min on average. And so to keep the max to min in check for parking lot applications, we drew the line at 30:1 max to min as an equivalent to 6:1 average to min. It was noted that not all tasks are rectangular, and this is definitely true. Most tasks do have a fair number of straight lines for their boundaries, but they are not rectangular overall. But they are typically not lit by a single luminaire either. They're usually lit by multiple luminaires on multiple poles. And to cover these large areas, the most efficient way to do this without significant overlap or spillover off the boundaries is with a rectangular pattern. This diagram gives you the basic idea. It is simplified to give the basic intent, showing that a circular pattern will tend to leave dark areas or create overlap or spillover, whereas a rectangular pattern will match up more efficiently. We do recognize that true right-angle corners are not ideal. It's not something that a manufacturer should strive for, because when you match these distributions up with one another, they do add to each other's light levels. And so you can round the corners a little bit and still be fine. And in fact, just in terms of physics, it's quite difficult to optimize for a truly squared off corner. It's not something people are likely to try to do, and they're not expected to do it either. There was another comment that the metric should score luminaires that cover large areas more favorably than those that cover small areas. And while it is true that a large area coverage can reduce system cost, it is not something that will ensure ongoing energy savings. They don't correlate. If you, as I mentioned before, if you tighten up your pole spacing because of a tighter beam, then you can and should reduce your wattage accordingly so that you're not overlighting the site. There was concern that the way we've structured the criteria, high output and unshielded luminaires, will be discouraged. And this actually is, we're not trying to discourage these categories, but this is the basic intent. We want to reflect accurate benchmarking of HID products that are out there. It's a fact that as you reduce shielding and increase output, HID products become more efficacious. And so therefore, LED products have to become tougher to compete. So we, rather than just blurring everything together, we broke them apart appropriately and set levels differently appropriately. So here we've got our proposed revisions to the criteria. Again, introducing the mid-output categories for shielded and unshielded, modifying the FTE requirements for all the categories based now on the 75th percentile, not 20% savings over the 75th percentile, and also doing away with the uplight allowances. So where does that put us in terms of products that are LED products that are out there? How many appear to be at the level they need to be ENERGY STAR qualified? This scatter plot gives you a quick snapshot of photometry that is currently available online. It has not been verified and approved. This is just a very preliminary sense of what we're looking at. And you can see that there are a number of products that would not have been approved under the previous baseline, but now are as far as the low output unshielded category. And where before it was only the shielded products that were passing, now we have more of the shielded low output that would be meeting our requirements. Moving to the mid output, where before we would have had only one product that appeared to be meeting our requirements that happened to be in the shielded category, as expected. When we adjust our baselines for the 75th percentile and introduce the mid-output category, we come much closer to meeting ENERGY STAR requirements. And this is a reflection of the market. Basically, at the mid-output level, it's not a sure thing that LED is going to save you energy. It's still very much a case-by-case basis. There is no chart for me to show you on high output because currently there are no high output LED luminaires to even go after this category. That will be something that will become more of a possibility in the near future. One last comment was regarding another metric, similar in some respects, called the Target Efficacy Rating, or TER, from NEMA. This metric was evaluated early on. We decided not to adopt it because of a few issues, including the fact that uniformity is not evaluated, and neither is the shape of the distribution. And backlight was actually totally disregarded, or in other words, discouraged for types 2, 3, and 4. We heard very recently that this may change, that the backlight may be considered for types 2, 3, and 4. And there is a vote scheduled for October 7th, yesterday. So we'll see what the outcome of that is. This would be a major improvement for the metric, basically going from something that's actually potentially harmful for the market to something that is helpful. Now, again, the limitations of the metric are that it does not evaluate uniformity, does not evaluate controlled distribution. These are two things, two great opportunities for LED to stand out in the future, offering greater potential control of distribution and energy savings from improved uniformity, particularly for parking lots. So what we see here is a type 4 distribution under the TER metric is currently defined, where backlight is simply discarded, and the target, which really isn't a target, it's basically boundaries that have been set so that light is simply discarded if you spill off these boundaries. This target is defined as being infinite left and right, and ranging from 0 to 4 mounting heights forward for a type 4 distribution. So basically, any flux that lands on this target or within this boundary is counted, whether it's spread uniformly or effectively or not. As long as it lands in here, it's counted. And so you can get some kind of squirrely distributions like this one that you don't know whether it's you don't know what the shape is. You don't know where light's really going if that's lining within this boundary. The proposed change would be to add 1 mounting height of backlight to this boundary. And so for the shielded luminaire, you would get a little more flux counted. And this actually is a pretty big deal for unshielded luminaires that are type 2, 3, or 4. You get a lot more flux credited to them that might be of use. So this is the end of my presentation. At this point, I want to thank you for attending this webcast. We will continue to consider your input as we finalize our criteria. Thank you.
Thank you, Jason. I will now turn it over to Kelly Gordon to go ahead and move forward with the Q&A session.
Okay, thank you, Terry. This is Kelly Gordon, also of Pacific Northwest National Laboratory, and I will be facilitating the question and answer portion of the webcast. Now, we've been receiving questions pretty much continuously as the presentations have been going on here, and we will be taking questions in the order that we've received them, and we'll attempt to answer as many as possible in the remaining time today. Now, questions of a logistical nature, such as where the presentation slides will be posted, etc., I'll just reference those once. We have several of those. And duplicate questions, of course, will not be repeated. We will be capturing all questions and reviewing all of those. So I want to assure you, if you don't hear your question answered, we will be reviewing them. What I'm going to do is again, taking the questions in order. I will answer some questions. Most of them I will be feeding to Jason Tuenge or to Rich Karney to answer. So I'd like to go ahead with the first question. It has to do with glare, light trespass, and sky glow. It says, I would like to thank the DOE for including educational materials about light pollution on the SSL website. And I should note this is separate from the Energy Star criteria, but it's materials that are on the DOE solid state lighting website. The details on glare, light trespass, and sky glow help everyone understand the proposed design criteria. I was wondering if the DOE would publish information on why it is helpful to control light pollution. What is bad about glare, light trespass, and sky glow that the design of outdoor luminaires should work toward minimizing these effects? I guess in answer to that, I would say that we know that glare, light trespass, and sky glow are concerns, and these really are design considerations that need to be taken into account at the level of designing a project or an installation. Now, at the level of the luminaire, this is one of the reasons that we're looking at a metric that goes beyond simple luminaire efficacy, beyond simply counting all the lumens that go out of the luminaire. We want to look at where they're going, and those certainly are issues that should be taken into consideration. Jason, I'll ask you to take the next couple of questions.
Okay. First up, we've got a big question about LED versus induction lighting. This comes up quite often. It actually came up twice just yesterday. Generally speaking, induction is going to have trouble competing when you've got broad pole spacings, or if you need to have control, say, of your house side light distribution, preventing light trespass. Where induction will be strongest is when you're most concerned with maintenance. It is a long life product, although you do need to pay attention to the lumen depreciation over time. This kind of product can work well in your glowy type decorative luminaires, and it can also work for closer pole spacings where you don't need to reach as far. And so it can be competitive in those applications. But by and large, LED is going to be competitive, and we're basically anticipating that it's going to go leaps and bounds beyond induction in terms of efficacy over time, and be available in a broader variety of products. So induction can be considered, but be aware of its limitations. It's also quite sensitive to heat, like LED. Another question: how long will LED lighting remain at its original level before needing to be replaced? The answer to that is it will not remain at its original level unless you do something in the way of dimming and monitoring depreciation over time and accounting for it with ramping up your levels over time. It will lower in output over time, just like other sources like HID or fluorescent. And basically, at this point, we're treating the point at which it's dropped 30% from its initial value as being its end of useful life. There's a lot of research going into this right now in terms of developing standards. Right now we have LM80 from IES to do the testing, the monitoring of this depreciation. And there's a document that's being worked on, TM21, that has not been released yet, and it's because this is still something ongoing in terms of research. TM21 will allow standardized forecasting of depreciation, so you can accurately, meaningfully state how long your luminaire is going to last. It's no longer just a claim. It's going to be a function of heat sinking and drive current, and we recommend including this in your warranty, basically to make sure you're covered, that it'll meet some light level over time. I guess back to you, Kelly.
Yes, thank you, Jason. Okay, I will take the next couple of questions that came in. First, why is the correlated color temperature, CCT, for LED for Energy Star qualification lower limit set to 2700 K? Basically, we're referencing the ANSI standard that defines chromaticity for solid-state lighting sources, that identifies 8 nominal correlated color temperatures. And we wanted to stay within referencing that standard. Now, technically, ANSI C78.377 is not applied to outdoor products. However, we wanted to have some definition so that people would have a common understanding of what color temperature they're getting. And so we do reference the ANSI standard. The next question, will the updated information be available online? I'm assuming this means a next version of the criteria. Yes, everything will be made available online, and there will be announcements that go out from the Energy Star program to inform people. There's a related question that I'm going to pitch over to Rich about what happens next. Rich, can you take that one?
Yes, the question came through asking what happens next on the implementation schedule. Will be further comment and review. We're going to be interpreting the questions that we get today as part of the comment sessions, and depending on the criticality of the comments that we receive, whether we'll have another comment period or not. We're looking to finalize the criteria for the outdoor lighting sometime within the next 4 to 6 weeks. So we want to finalize the criteria, get it out into the public, and then hand it over to EPA to handle the ongoing and further implementation at that point. Jason, you're next.
Sorry about that. Switch back over. The next up we've got is the lumen per watt metric based on delivered lumens or lamp lumens. Lamp lumens, well, in setting baselines, lamp lumens are definitely considered to set the lamp ballast efficacy for HID. But as far as the metric is concerned, in its use for LED products, Lamp lumens definitely do not apply. There is no such thing as lamp lumen ratings for LED products, at least not on a standard basis. FTE looks at the lumens that are delivered to the uniform pool, the uniform area of coverage underneath the luminaire, which are then scaled down by the percent coverage of the fitted target. So it is delivered lumens to the target in a useful manner. Next up, see on slide 39, talking about lamp ballast efficacy increasing with output. So as you get more output from a lamp, the efficacy of a lamp increases. 1,000-watt HID is more efficient than 100-watt HID, basically. And saying this really isn't a fair means of setting a baseline for LED, because LED typically does the opposite. Not always, but typically. And this is true. So for instance, if you increase the drive current for an LED product, you get more output out of it, its efficacy is going to drop, basically because of things overheating. The reason why we didn't look at it in terms of LED performance is LED is not the predominant incumbent technology. Whatever we label as Energy Star needs to compete out in the market, and therefore we used HID performance as our baseline. There's a note here about a press release released just yesterday from Dark Sky Association concerning concern over short wavelength light, i.e. blue portion of the spectrum, basically having potential health ramifications. And this has been an ongoing area of research. We are aware of this issue. This statement from IDA basically is raising the alarm. It's something that people have been aware of for some time, ourselves included. Basically, our stance at this point is that we need more research. What's currently available is not something that can be directly applied to lighting practice. So this is something that we're taking very seriously, but at this point we don't feel there's really cause for alarm. We are going to be producing a fact sheet and posting it online in the near future. Back to Kelly.
Okay, the next question was, is lumens per watt efficacy actual or test? And if I'm understanding that right, what we look at is the photometric test report for the luminaire. So in this case, it's absolute photometry according to IES test procedure LM79. So that is the information that is used to evaluate the performance of the luminaire. Okay, Jason, next question.
Question about uplight for use in garages. If you're in an application where you're not covered by anything, say on a pole or a wall, then uplight is clearly wasted. It's just going to go up into the sky. If you're in a garage, it actually improves the perceived brightness of the garage. It's actually a good thing. The problem is in determining just how much uplight you should have. And since it's really not clear just how much you should have, and because it is clear that any uplight you generate is going to be less effective, less efficient in producing the required light levels on the ground, basically we're not going to set a minimum amount of uplight for luminaires. That's going to be left to the manufacturers. If they use efficacious diodes, basically, then they should be able to have some uplight without compromising excessively the performance of the luminaire. Next up, a question about the bug rating system. Can't go into this too much during this webcast, but the basic idea of the bug rating system, well, it's detailed in ISNA TM1507 Addendum A. You can Google it and actually grab the document for free online. Again, ISNA TM1507 Addendum A, and you can see all the details there. Basically, that the lighting designer determines the lighting zone for a project. If they're in a dark environment, they're going to be working with luminaires that don't have as much flux in the high angle region on a lumen basis. And if they're in a brighter environment, then they can have more flux in the higher angle zones. Basically, just look up the values in the tables. This is an update on the cutoff classification system, which had no bearing on your actual location. Just look at it at the luminaire level. So then another question, where does floodlighting fit in? This is actually a good question. Basic answer is it does not fit in. The problem is that even a quote-unquote fixed luminaire can be installed on a hinge and tipped upward. So it's, preventing that's not something that we can do necessarily, but the intent is that floodlighting is, we're not going to take floodlighting products. So we'll look into adding a clarifying note. Another question, by deleting uplight allowances, we're going to effectively eliminate decorative products. That's not entirely true. As I mentioned earlier, it's difficult, basically impossible, to objectively differentiate between decorative and I guess non-decorative products. There are definitely decorative products out there that meet full cutoff. So basically, that category would still be eligible for Energy Star. But it is true, if you've got just a simple acorn that's throwing light everywhere, it's not going to meet Energy Star. Another question, having issues loading an IES file into the software. This has come up several times, and each time that I've looked at it, it's come down to poor formatting. In other words, non-standard formatting of the IES file. If you go online, you can find the link to FTE support, and I'd invite you to just send that through to me, and I'll take a look at it. I can probably fix it for you pretty quick. Next question, this is a kind of a stumper, frankly. Has the issue of IR radiation into the sky from the LED heatsink been considered in terms of interference with various systems? The answer is no. And I don't believe this would be a problem. We can look into it, but I'm kind of skeptical that the amount of radiation is going to be substantial enough to cause problems. Existing technologies produce heat. For the garage lights, asking about the baselines being set based on other technologies. And sorry, I'm reading this real time now. Didn't get a chance to answer this one proactively. Basically saying that it may not be fair to compare against other technologies, that other technologies don't have to meet the same robustness criteria. Long story short, we're working with the standards that we've got. Standards are still being developed, and in the meantime, we know what we're up against, and we're setting a reasonable bar of quality for LED moving forward. And in some cases, it's going to be a bar that's raised higher than the competing technology. For example, in terms of color requirements or color consistency. Next up is for Kelly.
Okay, the next question was the different lighting efficacy for different wattages right for HID luminaires, but not for LED luminaires. Analysis shows that low and high lumen output LED luminaires have the same lumen per watt values because they build from the same LED modules or bars. I believe we addressed this question in a slightly different form. It has to do with the baseline and why do the requirements go up when you're talking about higher output. Basically, as Jason has said, the baseline technologies, the HID technologies, get more energy efficient as the wattage goes up and as the output goes up, and so the requirement for LED has to ramp up as well in order to compete against those technologies. I'll bounce it back to Jason now for the next one.
Okay. Next question is, doesn't FTE depend on mounting height? And the answer is no. Uniformity was selected as one of the criteria specifically for this reason. Like luminous intensity, or candelas, the uniformity really doesn't depend on mounting height or distance. In the case of uniformity in the uniform pool, basically, as long as you define the size of the uniform pool in relation to mounting height, In other words, you set the mounting height at 2 mounting heights or 1 mounting height, whatever, but then the size of the uniform pool is scaled proportionately, then your uniformity is preserved. The relationship is preserved. That was the reason for choosing uniformity as one of the criteria. So no, it does not depend on mounting height. Basically, when you go to apply this, you would simply find the area of coverage that you need in terms of mounting height, and then fine-tune your wattage to get the light levels you need. That's the basic idea. Back to Kelly.
Okay, the next question says the website for the FTE tool doesn't appear to be in the downloadable presentation. Can you please email this out? I would say yes, we can email the link out. It is on the Energy Star website along with the draft outdoor criteria. But we can email that link out after the webcast. Jason, next question.
Next one up is discussing correlation between FTE and lighting power density. We've seen two stabs at correlating FTE and lighting power density thus far, both showing in their cases that basically there isn't a super strong correlation between FTE and lighting power density. And this is really to be expected because one of the fundamental bases of FTE is that luminaires will continue to be applied appropriately by the designer. If luminaires are not applied appropriately, in other words, if you have a luminaire that is type 5 and broadcasting a lot of light backward, and you try to use it to light a street, then you're going to have a very poor correlation between a product that looks very good in the eyes of FTE, but not so good when you go to use it to light a street. So that's kind of an extreme example to illustrate the point. But basically, the easiest way to break correlation between the metric and the application is to misapply a high-performing product. And so it's one of the tricks with lighting in general is that you really can't just pick a favorite and run with it forever. You really do have to look, reevaluate the population each time you go to design a new system to see what's going to work best for the job. See how. Oh, and then the follow-up question that I almost missed. How can a greater number of high-performance fixtures on a site be in the spirit of energy efficiency? Basically, the argument here is that if you're requiring more poles to be installed on a project because you've reduced spacing, say because you've got a product that does not broadcast over a large distance, a project where a greater degree of cutoff is desired by the community or the designer or the owner, is going to require more poles basically to get the job done. So there's going to be some embodied energy involved there. And our argument is that based on current research being done, for example, at Carnegie Mellon, that for the near future, what's of concern is the ongoing energy consumption. That's by far the bulk of the life cycle energy consumption of a system is the ongoing energy consumption, not the energy going into production. See, so next up here, looks like that one's me as well. What are the fixtures shown in the FTE charts? Good question. Basically went out, grabbed, you can see how many from the scatter plots, how many data points we collected, but went out to major manufacturers and grabbed basically all of their products that fit the category of shoebox or Cobra head, and just grabbed all their data and ran calculations and created the scatter plots from there. And so it's based on shoeboxes and Cobra heads, not based on, say, decorative products. Sorry, the next one is also me. 70 lumens per watt criteria should also be adjusted on the garage light. I think basically here saying that maybe we were relying too much on fluorescent, which is going to be more efficacious. We did also consider HID to see if that might, in averaging between the technologies, bring the bar down. And ultimately it did not, because the original bar was set on, based on some assumptions about fluorescent not having as great of efficacy in colder climates. So when you take another look at it and assume fluorescent's not being used in the colder climates, then you still run into the same level. So it's still valid. Kelly, you're next.
And I may need your help on this one, Jason. The question is, have you looked at whether induction lighting technologies will be able to attain ENERGY STAR qualification? At this point, the scope of this ENERGY STAR program requirements and criteria is for solid-state lighting technologies only, and I believe Jason earlier answered a question about how induction stacks up against some of the other technologies. Anything to add there, Jason? Yeah,
the basic answer would be that for certain product types, induction might be right there at the bar. They aren't going to look stellar most likely, but they may actually barely meet the requirements. But like Kelly said, they're not eligible. The same goes for various HID sources, high pressure sodium or metal halide. There would be a few that would meet the requirements, but they are not eligible. So next up, what are the fixtures? Oh, sorry. For pole-mounted LED luminaires, is shielding relevant given that the optics can do the same job as cutoff control? How is shielded defined? Okay, so this is also a good question. Looking back at the scatter plots, and I might have Bob bring up the scatter plot at this time. Give me 1 second to catch up here. Which slide in particular we're looking at? The best one is 31. Bingo. Okay. So basically in evaluating this massive data set, we looked for trends and also based some of our searching on experience. Basically knowing that, for example, as luminaires wattage increases for HID, so does its efficacy, as I mentioned before, because of line ballast efficacy. The other thing that is pretty well known is that as you control a luminaire more, as you shield it more, you're going to throttle it so that its total output is reduced. And so one of the first things we looked at was to see, okay, just by how much, and can that be used to actually identify what a shielded luminaire really is? Because if you try to do it mechanically speaking, you really can't. I mean, you could put in a little tiny piece of metal and say, voila, it's house side shielded. So really, and then other products, say a number of forward throw HID products, are inherently shielded. They're not advertised as being shielded, but there's really no backlight. It's just the nature of their design, a scoop type reflector. So basically we found that by drawing a line at 1.5 mounting heights for the uniform pool backward extent, that this did a good job of differentiating between the shielded and unshielded categories on an objective basis. Really the first time I've seen something of this sort. So I think that answers the question. We get back to the first part. Good job. I'm not getting the rest of the questions. Go on to Kelly.
Okay, the next question is, can you provide the products that relate to the points on the charts? I guess I'm not sure which specific chart, but I would say we didn't name the fixtures by name, and for the baselines, there are too many, but it's available published IES files from a range of manufacturers, and it ended up being hundreds of different files. If you're referring to the LED luminaires that were plotted on the chart to show how they would do against the revised levels, we didn't publish the names of those because luminaire or the Fitted Target Efficacy is one criteria that these products are being evaluated against, and in order to become Energy Star qualified, there are other requirements that must be met. So we wouldn't want to prematurely identify any particular products as meeting all Energy Star requirements. So we're not publishing those names. Jason, anything to add there?
I was just going to say, as far, we probably don't want to name specific manufacturers that we looked at, but be reassured we didn't just look at one. We looked at, I was just skimming quickly, and I can't really give an exact count, but it's something just under 10 different manufacturers from which we gathered all this data. So it's not 100, it's not one, but something like 10 different manufacturers. So it looks like the next question would be me, and saying favoring large areas of coverage is also a safety concern. Minimize accidents and system costs. So basically saying that a large area of coverage will both improve safety and reduce costs. Again, this ties into an earlier question. Our main concern is energy savings. And again, the bulk of energy savings is in ongoing energy consumption. We are not discouraging a large area of coverage. The only thing that would fall in line with that is the bug rating system that we've incorporated. And I guess this would probably be another good time to reinforce the earlier point, Bob. Let's see, with slide. Sorry, it's going to take me a second to find this. If we look at slide 16, thanks. Basically, you can see here that our use of the bug rating system is not being overly restrictive. And so really, when you get down to it, we're not discouraging large areas of coverage. We're not encouraging it either, and that's really for lack of guidance from IES, indicating or basically reinforcing this concern. So at this time, we are not rewarding people for a large area of coverage. I believe the next question is Rich.
Okay, I have two questions, the same on this latest set of questions came in. When will the final document be available? When will the criteria start to be implemented and available for use for the U.S. and outdoor lighting? As I mentioned previously, I expect the final document to be available in 4 to 6 weeks, and we're estimating a beginning effective date sometime in the first quarter of the calendar year 2010. Kelly?
Okay, the next question was for slide 5, ceiling mounted criteria. Is that for outdoor lighting or indoor lighting? Yeah, this is just for outdoor, and it is the parking, garage, and canopy application, just to clarify that one. Okay, Jason, next.
Yeah, the next one I kind of wish was a live question that I could get clarification on, because I think I know where they're going with it, but I'm not entirely certain, so I apologize. The question reads, on the type 2, 3, and 4, why not create the rectangle as with the type 1 distributions? I'm guessing what this means is basically creating a rectangle that's symmetric forward and backward, and basically penalizing luminaires that don't cover backward as well. Kind of a tough one, frankly. And then maybe, I guess the alternative way of interpreting that would be to fit the forward and backward separately. So you have two rectangles. Maybe that's what the point is. Basically, the idea is, in fitting a single rectangle to the whole distribution, the idea is that if you have backlight and you don't cover that backward portion of the rectangle, there's a pretty good chance that you're just letting light go back there. Maybe you've throttled it a little bit, but that light that's going back is probably not deliberate. if you've got rectangular forward throw but not backward. So if you're lighting a sidewalk, then left and right, the sidewalk's going to go relatively dark, while you've got a pretty good pool of light at the pole. Next up, how can decorative fixtures such as a pole-top acorn be expected to have zero uplight? That's something we touched on before, and as I mentioned before, acorns will have a tough time being Energy Star. Basically, acorn is not efficient in terms of delivering light to the ground. A lot of it's lost up into the sky. You can put in shielding and so forth, but you're still going to have some uplight. So there are other means of having a decorative luminaire that's not an acorn. And you can still do it, it just won't be Energy Star. Back to Rich.
We're going to pursue Energy Star ratings for HID luminaires also. The scope of the criteria we're discussing today is for solid-state lighting and ensuring energy savings of solid-state lighting compared to other technologies. So, go on.
Hey, Jason?
Yep. Got another one about the IES files. I'll move on to the next question. This is a very good question. Is there any specification on adding controls or dimming involved with outdoor lighting? This is a very tough one. We recognize that there can be substantial benefits to implementing controls for your project and further enhancing your energy savings. These controls can also be applied to predominant technologies, especially fluorescent, so keep that in mind. I think the main problem is that controls are really best evaluated at a project level. You really need to know what's happening with the project so you pick out the right controls. We have considered things like creating a separate category for luminaires that have integral controls. But to go into there basically gets into some pretty muddy water. You're making a lot of assumptions as to what's going to work for the site. And it just being controllable really is not enough. You can't assume that somebody's going to take a product that's controllable and then control it on their project. So it's something we'll continue to evaluate. It offers tremendous energy savings, but it's not clear-cut. So we're not incorporating it at this time. Back to Rich.
What is the Illuminating Engineering Society's involvement in these criteria? Let's see. Throughout all our deliberations and evaluations and analyses, we've relied on IES standards and test methods to the greatest extent possible for the solid-state lighting criteria we've established. For example, we've used the BUC criteria, IES uniformity criteria, and LM79 generated IES photometric files as the basis for these criteria. We have a very good and close working relationship with IES, and we accept their input. We get input from their members, and they've been highly involved in our Energy Star criteria setting.
Next question. Regarding ceiling-mounted products, so why setting a requirement for zonal or minimum lumens in the 60 to 70 zone rather than 60 to 80? Basically, the 60 to 70 is generally well accepted, established as basically the performance region. As you approach 70, and really even in the 60 to 70 region, you've got a balancing act between potential for glare and performance, basically allowing spacing of luminaires, broad spacing. So once you get past 70, it seems pretty clear that people are going to be more and more likely to experience glare, basically. So it's not clear-cut, but basically the 60 to 70 zone is a little safer, and it gives us a good means of getting the pulse of the product and getting a sense of, is this thing distributing light without effectively encouraging excessive light in the glare zone. Next up, how is backlighting defined? Yeah, and so again, this is something we touched on earlier. It's getting further into use of mast arms and sidewalks behind the pole. This is really why the metric was developed the way that it was. Basically, we knew that we did not want to simply discard backlight like some other metrics do or did. So we did allow backlight, but we penalized luminaires, effectively penalized luminaires if they did not control their backlight. So again, we enforced rectangularity and or encouraged rectangularity, and thereby allowed backlight for things like sidewalk lighting from mast arm mounted Cobra heads. But again, it comes back to a qualified designer picking out the appropriate product for the job, because you don't always want backlight. Next up, does FTE apply to ceiling mounted? We did consider using FTE for ceiling and wall mounted, and basically came to the conclusion that for these categories, the level of specification isn't quite as high. The diversity of products isn't quite like it is for roadway and area lighting luminaires, and so we decided to keep the metrics basically proportionately simple for these other applications. You just don't find Type 2, Type 3, Type 4 used in garages or even for wall-mounted products, for example. Next up, has there been any field verification of the FTE method? On the ground, power consumption checks. So the basic answer to this is no. The metric is fairly new. We have been basically checking it against projects in our Gateway demonstration program, and including the metric in reports. I don't believe any of those are posted online yet, but they're basically in development. And so far, we're finding good correlation between FTE and performance in the project, provided that luminaires are well suited to their application. So this is not always the case. We're not always the ones selecting the HID luminaire, for example, and it may have a fair amount of light that's not going where it needs to go. So it may not be optimal, in other words. Next up, here we go. Okay, so this is getting into basically drawing a line between products that are intended for mounting above eye level. We're not covering products that are intended for installation below eye level. So the question is, what height is eye level? Basically, the safe answer to that is seated. Your seated eye height, which I don't recall exactly off the top of my head, but I want to say it's something like 3.5 feet, roughly. So I think that's 42 inches. I think that's a pretty standard height, and bollards would fall below that, as well as step lights.
Okay. Should we let Jason breathe for a moment, Rich? And you want to take the next one?
Sure. We had a question that came in. I just heard comments regarding solid-state lighting and induction. Shouldn't the DOE's approach be technology independent and driven purely by energy savings and applications? The approach comes across as being pro-solid-state lighting instead of pro-energy savings, irrespective of technology. Well, from the get-go, DOE made it clear that these criteria only apply to solid-state lighting products because of the unique nature of these products and the unique standards and test procedures that apply to them. The department was directed by Congress to launch a major research, demonstration, and technology commercialization initiative, not for all technologies, but for solid-state lighting. And these criteria are part of that initiative. Jason, did you catch your breath?
Yeah. I almost fell over there. Next up, we've got another question about decorative products, concern about them being excluded. Again, what we're concerned with here, if your product's going to be Energy Star, it's not going to be Energy Star just among LED luminaires or just among acorns. Energy Star products are going to be performers. And so you may have a product that is very attractive during the day and at night, going beyond just producing light for a task, but you are still going to be held to the same standard, and that includes no light wasted uplight directly. So, an example of a decorative product that would be okay would be, say, a lantern that does not have luminous sides. It's got the optics tucked up inside. That's still decorative, still historic, would look, historic by day, and it could still meet Energy Star. There are certain designs that are going to be luminous from up in space no matter what you do to them, and those are the ones that will be cut out. Back to Rich.
In comparing solid-state lighting to linear fluorescent, is the whole environmental impact considered? Don't we want to encourage the elimination of mercury in our lighting? Well, here our focus is on minimizing energy use. That doesn't mean we ignore environmental issues. It just means we focus on energy use in these criteria. For instance, DOE has addressed mercury in CFLs by limiting the amount of mercury that can be used in Energy Star qualified compact fluorescent lamps. But we are setting Energy Star criteria for fluorescent lamps in these criteria, so we're not addressing their mercury content in these criteria. Jason?
So next up, I'm talking about basically setting the bar based on predominant incumbent technologies and percent market share. Basically saying that, asking, what data did we use in establishing percentages of different products? Say, what percentage of gas station canopies are metal halide as opposed to some other technology? And we definitely had to make some assumptions. There's data just simply is not available with that fine of resolution for these various product categories. And so there were definitely some assumptions made, but it was based on observation and consensus. So basically, you will find that these are valid. Next up.
Okay, I think there's a couple of questions that I can address. One, is there an available updated FTE calculator to use? I assume that means with the new proposed requirement levels. No, we have not posted that yet. We're just presenting the proposed revised levels here in the webcast and asking for feedback from those who are participating in the webcast, and then we'll be using that as we revise the criteria. So once we have reached the final level there, then it would be updated. So it's not updated currently. The next question, will these new Energy Star standards override IES standards? No, not at all. Energy Star is different from the IES. First of all, that Energy Star is a voluntary program. The IES sets also voluntary standards, but they're industry-accepted standards. And I would say we very much reference IES standards, as has been detailed previously, and will continue to do so. So we do not want to be in conflict with IES standards. Okay, Jason?
Okay, the next one. Asking about other metrics, basically. We consider other metrics, for example, NEMA's TER as defined in LE6. We did evaluate TER early on, before even starting on FTE actually, and came to the conclusion that for a number of reasons, it didn't quite fit our needs. One of those reasons, apparently, is mentioned during the webcast, might be going away, greatly improving the metric. Basically, at this point, we still feel that FTE is the better metric for our purposes because it does evaluate uniformity and control of the shape of the distribution. NEMA really doesn't do that, or sorry, the NEMA's TER does not do that. Under their metric, all you have to do is land within the boundaries. Whatever happens inside those boundaries, it's blind to. It's just as long as you land within the boundaries. So basically, we feel that FTE is going to do a better job of recognizing performance of LED products as they move forward and as they demonstrate their potential for control of the distribution and improving uniformity to save energy in applications like parking lots. So I think that's it at this point for that one. Next up is the Unified System of Photometry. Yikes. I believe I have a sense of what that is. I probably shouldn't drop names. But frankly, I'm not familiar. So I think I'm going to have to skip that and move on to the next one.
I think what we can say in response to that is that we're using industry standard photometric measurement standards and test procedures here. That is what underpins all of the metrics that are used in Energy Star is the LM79 test method for solid-state lighting luminaires, and that is all based on industry-recognized methods of photometry.
Yeah, I believe that there's a new system being proposed and discussed among committees to unify basically, the IES standard with, I forget the name, but a European standard. Mm-hmm. I believe that's about. That's not something that we've had to touch yet. But if and when it becomes something adopted by IES, then of course we will update the software to accommodate it. So ANSI CCT standards limit possible efficacy. Sorry, I'm going to have to read this question for a second. Yeah, basically at this point asking us to deviate from the ANSI NEMA standard for chromicity for solid-state lighting, which, as I mentioned before, is more stringent than what fluorescent, for example, faces. We recognize that this is raising the bar a bit, but for lack of any other standard, really, we are going with this NEMA standard, and it is definitely a robust standard, something solid to point at. So we are going to continue to use this, even if it is a little bit stringent relative to some other technologies.
Kelly or Jason, we have just a few more minutes for today's webcast. I think we can take maybe 2 to 3 more questions, and then we need to wrap up.
Okay, very good. Maybe just the next batch, Jason, and then we'll be done. Okay, another question is can you give us any sense when TM21 is likely to be finalized? I'm afraid I can't. What we hear from those who are involved is that it is a very complex topic. This again, TM21 is the committee that is seeking to address how you predict the lifetime of LED products based on, as you know, the LM80 test procedure provides a minimum of 6,000 hours of lumen maintenance data for LED devices. And then how do you extrapolate that information is the question. So I cannot give an estimate as to when TM21 will be finalized. Okay, Jason, take the last 2 questions, and then we'll close.
Okay, asking for a link to the software. Bob, if you can help out with that. I'm going to try to navigate quickly to the link. Looks like it's 23. You might have already been there. Bless your heart if so. Let's see. What percentage of LED products in the market have LM79 test procedures available? That's a tough one to say. Basically, at this point, it is very clearly gaining momentum. It's basically, you mentioned LM79 to any manufacturer, and they're going to know about it now. Maybe a couple of years ago, they wouldn't have heard about it, maybe just as a buzzword. But at this point, they know about it, they're doing it. The percentage that have been tested is another matter, but it's definitely a valid thing to be requiring, and something that is reasonable to expect.
Okay, and I think we'll close there, Terry.
Thank you for participating in today's webcast brought to you by the U.S. Department of Energy. Have a great day.